Ladies and gentlemen, welcome to the Connect Conference 2021 Day 4, brought to you by Wang.
Good afternoon, everyone, and thank you for joining us this afternoon in one of our technical sessions. Just a very big thank you today to Huawei for coming on board and helping us pull this one over the line. Thank you to Team Huawei for always being there, for helping us and supporting us through supporting our events and the Digital Council in general. So today it's a really big pleasure for me to introduce our next speaker. Most of you probably know our colleague, Mr. Tommy Wang from Huawei. Tommy is based in Johannesburg. And yeah, it's a wonderful pleasure for us to have him join us today. We're going to be talking about building cost-effective gigafiber networks, but a specific focus on the Huawei AirPON solution. By way of introduction, Tommy has got more than 20 years experience in fixed networks. He has, in South Africa alone, worked on projects such as Telkom, South Africa, the network revamp and FTTH side as well as MTN South Africa. And then he's also focused on and worked with Safaricom in Kenya, with Mauritius Telecom and with Telkom FTTH. So by way of introduction, we're very privileged to have him here. He's a home broadband business and network consultant and a specialist in transmission and access networks. Welcome, Tommy. It's a great pleasure to have you with us today and to have you join us. And at this point, I'm going to hand over to you and give the floor to you, so to speak. And I just want to thank you for your time and sharing some of your technical expertise with us today.
Good afternoon, ladies and gentlemen. So today, my presentation is a Huawei AirPON solution, build a cost-effective gigafiber network. And I will introduce Huawei AirPON solution. And second, I will also introduce the QuickODN solution. So as we know, in the past several years, the FTTH deployment speed up in South Africa. And for the ISP and operators, they still facing a lot of challenges for the FTTH construction. The most issue is the long-term deployment for the FTTH network and high cost. And the reason is three of them. First is insufficient CO site. That means there's no enough infrastructure for the exchange room to deploy the FTTH network. And also the site acquisition is as long as 6 weeks. And the second is there's insufficient skilled engineers. That no technician can doing the good work for the FTTH deployment. And the distance for the ODN network is quite long. So this will cause the deployment period for the FTTH project normally is more than 6 months. And the third, due to these two reasons, the high cost will reach more than $500 for the home pass. And the return of investment will be more than 6 years. And there is the same reason globally. Based on Huawei statistic in Latin America, the FTTH deployment cost is around $400 for each home connection. And the ROI is also more than 5 years. The reason for the high cost is due to the detailed. Here is a breakdown for all the cost, and we can see the civil work and the ODN service. This is always related to the outside plan, account 70% of the total cost. And for the civil work, 40% of the cost. ODN service device 30% of the cost. So the ODN part is the most reason why the FTTH investment is very high. And Huawei introduced AirPound solution to address these issues. Why Huawei call it AirPound solution is because now at this moment, most of the mobile operator, they also deploy FTTH network. And the Huawei AirPound solution is leverage the existing BTS site. We deploy the Huawei Blade ORT on the BTS site to reuse the uplink and the site power. Then from the site to precise cover the closed customer. So this can shorten the distance from the CO site to the BTS site. And from the BTS to the end customer, for the ODN network, we deploy the DQ ODN. That means a digital quick ODN. The quick ODN means we are using the splicing-free solution. All the ODN networks, there are no any of the splicing, just plug and play. And all the ODN network can work with Huawei NCE platform, realize the management. So with this solution, we can have the below highlight. First is zero site acquisition. So for the site acquisition, we just using the existing BTS site and the power and uplink, or shorten the deployment for the ORT from 3 months to 3 days. Second is zero fiber splicing. The end-to-end deployment of the ODN network is non-splicing solution. And for each site deployment, the installation time will reduce from 40 minutes to 1 minute. And the third is zero configuration. Because for the ORT and ONT, they go automatically configured from the central office. So we don't need to do the site configuration. So this will also reduce the service provisioning from 1 week to half days. By this way, we can shorten the ROI from 6 years to 3 years. So here, I will introduce the Huawei ORT first. You can see there's a video. The one engineer can carry one blade ORT to do the installation and all the fiber connection from the outside. And only the uplink fiber can open the cover, and when finished, close the cover should be done. And this installation only take like 15 minutes for per ORT. And this is the Huawei Blade ORT solution. So this solution has 3 highlights. First is high density. For the quite small ORT can support up to 16 GPON ports, can support up to 1,000 users per set. And the upstream can support up to 4 GE or 10 GE uplink. And second is high reliability. The outdoor protection is IP65, means that can work in the outside with the rain and the dust free. And the temperature can support up to 50 degrees. And the third highlight is easy deployment. For this, Blade ORT is just like a Blade RRU, so can easy to deploy at the BTS site. And the light weight is only like less than 15 kilogram. So one man can easy to carry and install the Blade ORT. And for other solution, we also have the auto cabinet. We call the M50 cabinet. With this solution is same as the blade ORT solution. The difference is with this M50 cabinet, we can install the mini ORT inside. This means we can easily to do the expansion. For the blade ORT, can support up to 16 GPON port. But for the mini ORT cabinet, we can expand the capacity to 32 GPON port. That makes sure that one ORT can cover 2,000 customers. And these two solutions have the same connection. We can use the same the connector, the cable through the outside. We don't need to open the cabinet, and we can doing the fiber connections. So this is the Huawei ORT solution. And for the second part is QuickODN solution. So first, we can see what is the challenges for the traditional ODN. Here is a diagram for a traditional ODN. We can see from the central office, we have the ORT and the ODF. Then we will deploy a big bundle of the fiber to FDT. And the first level splitter will inside the FDT. Then we'll have several closures to connect to the end customer will using the FAT. And the second stage splitter will accommodate in the FAT. By this way, there's some of the challenges. First is for the FAT installation, the process is complicated. Normally will take 20 steps and more than 12 tools. And this also related the skilled workers. We must have the technician, and they can handle all the tools to do the splicing and provide the high quality splicing. And sometimes it is possible, it is not possible to provide the high quality the splicing. And the third is for all this information of the FDT, FAT, and ODN network is input manually, and all the information record with papers. So in some cases, some of the information will missed, and then our ODN network resource also will missed. So this will waste our investment for the ODN infrastructure. And this also related the inaccurate information of the ODN network. When we do the service provisioning, will take some time to verify if the information of the ODN is correct. And in some cases, the service provisioning will also fail. So this is the challenges for the traditional ODN. Let's see Huawei DQODN solution. Huawei DQODN means digital quick ODN. As I mentioned, firstly, we can see the bottom. That is the Huawei quick ODN. The Huawei quick ODN includes the hard box, sub box, and end box. And for the hard box, sub box, end box, and to the ONT, there's all splicing free connection. So this will make the connection very fast. And the second, because for each of the hard box and the sub box, we have a QR code on the box, and we can use a mobile phone with the app to take a photo of each of the ODN device. And with the device QR code, we can recognize each of the ODN information. And also for each of the fiber, they also have a QR code here. And all this information can be recorded and sent through the mobile app to the NCE platform. Based on this information, we can generate the topology of all the ODN equipment and showing all this on the GPS map. Then with the accurate information of this, we can provide the fast provisioning. So this is the Huawei digital quick ODN solution overall, and I will give the detail next. So here is a Huawei quick ODN solution. So for Huawei quick ODN solution include one is a hub box, then is sub box and end box. From the hub box, we can install a 1 to 2 splitter inside. And for the hub box, the output is pre-connectorized connector. And for sub box, we just use a single core fiber to connect to the hub box. One hub box can support up to 8 output, and for each output can connect one chain of the sub box and end box. For each chain, we'll use 3 sub box and 1 end box, and each of the sub box or end box, the output can support 8 residential customer. So here, we just using the single core fiber as the distribution cable to connect all the sub box and end box. So this is the same device like the FAT. So here, give some detail why we can use single core fiber to do the cascading. No, for the cascading, we can see if we use a normal 1 to 2 splitter to do the cascading, the power budget will drop down very fast. It means for the last FAT, there's not enough power budget for the connection. So while we use the uneven splitter, the 30% will go to the 1 to 8 splitter to connect directly to the end customer, and 70% of the power will pass through to cascading the next sub box or FAT. So in this case, we make sure there's enough power budget for the cascaded FAT. So this can support one chain up to 4 FATs and can support 32 customer for one chain. So with this solution, we have the highlight. First is we only use single core distribution cable and end-to-end plug and play. Second, we can provide the high quality. The high quality is guaranteed by the connector, is not by the splicing. So when the network is designed in high quality, then we can guarantee the quality. Third is we can easy to do the splicing free installation and improve the TTM. And the last one is the maintenance cost also reduced. Next, I will give the detail. So here is a comparison between the traditional ODN and the quick ODN solution. First, we can see the logical topology. For the traditional solution, ODN solution, the logical topology is the star You can see one stage, second stage, but the connection is a star. But for the quick-coding solution, the topology is like a chain. And for the physical topology, when we're doing the installation, we can see for each of the FAT and the closure is like the chain. And for the quick-coding solution is also a chain. So for quick-coding solution, the logical topology and the physical topology is same. And for the component is almost same. For the traditional one, we have FAT, distribution cable, and the job cable. And for quick-coding, we also have the FAT, that is subbox, endbox, and the distribution cable is only a single core. And the job cable, is also with a connector, pre-connect rest. Here we can see some detail. Here is for the traditional solution. You can see we use a 12 or 24 core fiber, and for each FAT we only take one core of the fiber, but we still using a 12 to 24 core cable here. And for the quick-coding solution, from the hard box to the end box, we just use a separate one core pre-connector cable that is cascading each other. This is the cascading mode. And the second is for the traditional FAT. When we're doing the installation, we'll take more than 20 steps. Like we cannot doing the splicing on the port. So first we must take the FAT off the port and doing it on the ground. Then we open the box, we peeling, we fix and seal the cable, we window cut and do the fiber routing. Then we use the splicing machine to do the splicing, routing again and close the port, then install back on the port. And we still will reserve some of the cable to make sure for future maintenance. But for the quick-coding solution, it's quite easy. But one man can come to the port and we can do the installation of the fiber on the port directly. So one people can do it less than 15 minutes with done. And the second is the implementation of the cabling. For the traditional cable and the FAT installation, we must install first one pole, then the first deploy the cable FAT, then to the next pole, we deploy fiber FAT. We must do it one by one, step by step. But for the quick-coding solution, we can do the installation of the FAT and the fiber separate. So we have two teams. One team do the FAT installation, another team do the fiber installation. And when who is the last one finish the job, they just doing the connection will be fine. So by this method, we can save 30% of the time for TTM. And for the network recovery efficiency can also improve more than 90%. For the traditional way, if there's a fiber cut, we must deploy a new closure here and to do the splicing inside. From the left side and the right side, and we connect all these cables inside the closure. They'll take like more than 5 hours and more people there. But for the quick-coding solution, it is more easy. It's a fiber cut, we just replace the fiber with the new one. If the equipment have problem, we just replace the equipment will not affect the other service. So in this way, with just 1 or 2 people, 30 minutes will done. So that will also increase the customer's experience. And for the indoor solution, we also have another type of quick audience solution. You can see this is a very small box. And this box, we use the same diagram as the previous quick audience solution. The difference is this is a box FAT is quite small, it's only like 1 hand big. And the distribution cable is built inside. We just turn the cover and we can take the fiber out from the inside to do the connection. This makes sure the deployment of the FAT inside the building will more easy and the cost will be quite low. And in some cases, if there's a duct, we can have the blatant solution. We take out the cover, we'll drag the fibers through the duct. Then we do the connection, we just put the head on. That is also quite easy. Here is the cases in South Africa. In South Africa, we already help telecom to deploy the quick audience solution. So you can see in the left is the real video to deploy the FTTX solution. And here you can see this is the hub box on the pole, the sub box, and this is doing the connection, and we also have the box on the wall. With the Huawei quick audience solution, before we have one team with 4 to 6 people per day can only deploy 1,000 meter fiber. And now with the team with only 3 to 4 people can deploy 1,800 to 2,500, the double the efficiency. And for the FAT installation, before one team can only deploy 8 FAT. Now one team can deploy 18 to 25 FAT. And for the splicing, we saved almost 80% of the splicing work. That is the quick ODN. Now next I will introduce the digital ODN. For the digital ODN, we have 2 parts. You can see. First is for the home pass. In this phase, we use a mobile phone to take a photo of the ODN equipment, and at the same time, also the fiber QR code will take photo. And then we send the information to the NCE platform. We can get the GIS information of each of the sub-box and all the connection and the fiber relationship information. So by this way, we can have the topology of the ODN network. And then for the home connection part, we also take a photo and we related the job cable with the ODN, the ONT. Then we have the topology information of FAT, job box, job cable, and the ONT. So by this way, we have all the detailed information for the ODN end-to-end network. And all this information is automatically through the photo, then sent to the NCE platform. And with all this information, we can provide the virtualized ODN topology. Based on the GIS map, we can have the physical route information to easy to find all the ODN route and the equipment. And the second, is visualized ODN details. And we can see here is the information for each of the FAT box, which is connected and which is still available for future connection. It shows all the details. Third is for the whole area, we can base on different domain to manage. If there are two teams, we can set separate domain, one with one area. So the two teams will not interfere each other and avoid the misoperation. And that part is for the DQODN, is a static information. And here, while we introduced the fiber iris solution, with the fiber iris solution, we can realize the real-time management of the topology and the fault management. So here, I give some more detail. For this fiber iris solution, first, we will deploy the OAI card in the ORP. And for the FAT subbox, a same subbox, but for each of the output, will have a built-in iris. And for the ONT, can recognize the information. So by this way, when we're doing the test, we'll send the test view from the OAI card. And with the built-in iris for each of the output, they have different iris and will change the face of the text wave. And for the ONT, they can only receive the specific wavelengths from each of the output. So this will generate all the information. And when this ONT is power off, and we will find out this is different, the wavelengths cannot received by the OAI card, then we will know this ONT is power off. And if there's a fiber cut, the reflection of the wave can also received from the OAI part. Then we can find out which of the fiber is broken and the distance of the broken point. So by this way, we can realize the real-time management for the ODN network. And we have three user cases. First is remote auto acceptance. And the second is real-time ODN topology update. The third one is the fault location. So now I give the detail of these cases. So here is the flash for the remote acceptance. When we install the subbox, and at the same time, we'll send out the information to the NCE, like the box is online, and also the GIS map. This is taken by the mobile phone. And also we can send the information for the power link loss for each of the subbox and the output. And there will also give a detailed information for the end-to-end power loss and if it is in the benchmark. This is the auto acceptance. And the second is refreshing in the real time. And here, when one new user is online, and at the same time, we'll get all the information of this ONT and generate the topology to which FAT connect to the end user and even for the power budget. This is the refresh restoration of the topology. And the last one is for the fault location. You can see when there's something wrong with the network, and we use a one-click fault location for the link, and easily we can analysis to find out that all the ONT after this stop box is offline. So we can find out that the fiber between the first stop box to the second stop box was cut. And we can also identify the fault location. There is the real distance of the fiber cut. All right. So that is all the 3 user case. And thank you. That is all my presentation for Huawei AirPound and the quick ODN solution. Thank you.
Thank you very much, Tommy. That's certainly been very interesting. I think, you touch on really interesting components. I think from a telecom space, we're all really concerned, really about 2 things, and that's, the cost to deploy and the time to deploy. And this was a really interesting presentation touching on both of those aspects and really making it clear how this Huawei solution can contribute to finding more cost-efficient and speedier deployment methodologies. So thank you very much. I think we're out of time, and I just want to thank you for your time today and contributing to this. Then for Team Huawei in general, that's always very supportive of the work of the Digital Council. Thank you very much for always supporting the work that we do and firmly believing in everything that we do. Take care, everyone, and we'll chat later.
Ladies and gentlemen, we trust you enjoyed the session. Thank you to all our sponsors and partners for helping us bring this event to you. Please click on the next link to join the following session.